Today we're going to continue our look at the atom and look at specifically ions. Now remember that in terms of what an ion is an atom that has changed its number of electrons. Remember, looking back, we had discussed the idea that all atoms are electrically neutral. Now, all that really means is that inside of an atom, the amount of protons equals the amount of electrons. But sometimes atoms can change. Sometimes atoms can lose electrons or even gain electrons. And they do this in an effort to do what we would say, they do this to become stable. Now what that means is it means they do this to try to get themselves to a point where they don't react. They become unreactive, if you will. Now you think about it, you take two materials and you mix them together and you know that sometimes they produce a reaction. Like maybe in middle school, you took baking soda and you took, vinegar and you mix them together and you saw that they maybe produced somewhat of a reaction where there was maybe an explosion, if you will. You saw it maybe come out of, maybe you made them a volcano. And so that's generally what we mean when we say they try to become stable or they try to become unreactive. They simply mix with each other, they produce what we call a chemical reaction, and in the end, they become stable. So the way that they can do this is either by gaining electrons or by losing electrons. Now you think about it, this can be hard to understand, but remember that electrons are negative, right? They're negatively charged. So if they gain electrons, an atom becomes negatively charged. Atoms that lose electrons, well, they become positively charged. And simply put, it's all goes back to the idea that protons are positive in nature and electrons are negative. Now, how do we know what they actually do to become stable? Well, it's based on something that we call the octet rule. So let's take a look at what that means. The octet rule simply says this. It says that atoms want to have a full octet, or they want to have 8 valence electrons. Now there is one exception to this. You probably remember from elementary school or middle school, you probably made atoms where in the very first level, maybe you had to do something like this where you made levels and you had to put certain amounts of atoms on each level and you had protons and neutrons in the middle and so on. And you remember maybe that in the first level you'd put 2, and then you were told to put 8 in the second level, and you were probably told to put 18 in the third, and so on and so forth. Now, we have a name. We call those Bohr models, but we don't do Bohr models in high school. We do something slightly different, something slightly more accurate, if you will. So in terms of understanding, all elements, all atoms want 8 valence electrons to be stable, with the exception of those first couple elements, because as we just mentioned, the first level in an atom will only hold 2. So hydrogen, lithium, beryllium, even helium, because helium is actually a stable element, they all will only need 2 valence electrons. Now, I say that, understand that the way then that elements will become stable, the way that they'll have what they need in terms of valence electrons, which means electrons in the outer energy level, is based on what they are. You think about the makeup of the periodic table, and as we get a little bit further, we're going to learn that elements are actually in specific locations. The metals tend to be found on the left side of the periodic table, non-metals on the right, but metals tend to lose electrons to become stable, and non-metals tend to gain. So another way you might put it is metals tend to become positively charged, and non-metals tend to become negatively charged. All right, so let's continue on. So in order to understand this, let's just start with what valence electrons are. Now, like we just said, they're electrons found in the outer level of the, that should say of the atom, not of the electron. So in the outer level of the atom. Now, they're based on the columns, and we think about the periodic table, and if we were to just draw a rough sketch of what your, periodic table looks like, and you have one at your table, so you could even take a look. But it looks something like this, right? And we see a column over here, so 1 and 2. And then we could go ahead and skip this middle section for right now. We'll come back to that later. But we would see then 6 columns over here, like 3, 4, 5, 6, 7, and 8. And those 8 columns, that 1 and that 2 and that 3 through 8, those are all the valence electrons. So again, whatever column the element's in, it tells you the amount of valence electrons. For example, go ahead and grab one of those periodic tables and find hydrogen for me. And when you find hydrogen, you're going to see that hydrogen is in column 1 on the periodic table. It's all the way up here in this corner. It's in column 1 because hydrogen has 1 valence electron. And go ahead and look and see what column oxygen is in, and you're going to see that it's actually all the way over here in column number 6 because oxygen has 6 valence electrons. Alright, and so as we look at these, we could see that for whatever element we want to discuss, that we could simply find where it's located on the periodic table, and we would know how many valence electrons it has. Now, from this, the next step that we could do is we could draw what we call a Lewis structure. And a Lewis structure simply shows us that. It shows us the symbol of the element, and then it shows us valence electrons as dots. Now remember that it can hold up to 8 electrons, with the exception being helium that can only hold 2. So if you wanted to look, a basic Lewis structure is going to look something like this. You're going to see the symbol, and then you're going to see dots around the atom representing valence electrons. Alright, so some examples of Lewis structures that we're going to see, and here's 2 of them. We see here chlorine and carbon. Some things to notice about it. So we see chlorine. Notice chlorine has 7 dots, just like we would say chlorine has 7 valence electrons. Now if you look and find chlorine on the periodic table, you should notice that chlorine is in column 7, right? That it's got column 7 because it has 7 valence electrons. That's why we then see So it's why you see then 7 dots on the chlorine atom's Lewis structure. A couple other things to notice. So notice that some of those dots are paired. These 2 dots over here are what we would call paired electrons. Whereas notice this 1 dot unpaired, that's important because that's where we're going to see what we call bonding occur. That's where we're going to see things like losing or gaining of electrons. Now remember from the previous slide we said that nonmetals tend to gain, whereas metals tend to lose. Alright, looking at carbon, same idea. Notice with carbon, though, that all of its electrons are unpaired. Again, that would be where we're going to see what we call bonding occurring. Alright, so let's go ahead and look at what Lewis structure should look like. The general pattern for a Lewis structure is going to look something like this. So if we picture X as the symbol and we picture the numbers as the order, so electron 1 and electron 2 and then 3 and then the 4th, and then the 5th, and then the 6th, and so on and so forth, we simply see the order at which we would put the electrons in. Now, I'm going to give you a minute right now. I'd like you to go ahead and copy down what you see on this slide so that you have... I'm going to give you a minute right now. I'm going to ask you to go ahead and copy down what you see on this slide so that you have this in front of you to be able to use as we do some Lewis structures on the next slide. All right, let's go ahead and let's take a look at Lewis structures. Now, here's the general rules. The general rule for Lewis structure is you're going to start by writing the symbol of the element, and then based on the column the element is in, you're going to add electrons for a maximum of 8. Again, remember, we do not count the 10 columns that are in the center of the periodic table, and then we just add the dots, right? We count the amount of valence electrons, and then we add the dots as we saw. All right, so let's just do some. So let's just say we wanted to do hydrogen through the first 20 elements. All right, so we're going to start again by identifying valence electrons. So hydrogen, being in column 1, it has 1 valence electron. All right, and so now we're going to write or draw where that 1 electron would be. We'd start by writing the symbol and then drawing a dot to show that 1 electron. That would be the Lewis structure for hydrogen. All right, so let's do helium. Helium, which has 2 valence electrons. Remember, we said helium is an exception, and so it, while is in column 18, it has only 2 valence electrons, and again, we'll draw those 2 electrons. So what do? We've got 1, and then remember, the picture told us to put the other one up here, so there's 2. All right, after helium is lithium. Lithium is back in column 1, so 1 valence electron. All right, so we draw the symbol. Then we're going to put that 1 dot, and we're done. All right, let's keep going. So next element is beryllium. Beryllium is in column 2. It's got 2 valence electrons. So we're going to put Be. This is a symbol. And now how many dots? 2 dots. So 1 and 2. All right, now let's do the next element after beryllium. After beryllium is boron. Remember, we skipped those middle 10 columns, so we go to boron. Boron is considered to be in column 3. 3 valence electrons. All right, so we're going to draw the symbol, boron, and then 1, 2, and 3. All right, next element, carbon, which is symbol C, 4 valence electrons. Again, how do we know? Because it's in that next column, right? So remember, we skipped those middle columns. So we had column 1, column 2, and then we moved over to the right side of the periodic table. So next column is column 4. So 4 valence electrons. And then remember how we had it drawn? There was 1, 2, 3, and 4. All right, after carbon, next element is nitrogen, symbol is N. It has, if carbon had 4, nitrogen has 5 valence electrons. Again, how do we know? Based on the column that it's in. So now what are we going to do? Symbol, which is N. And then now we start adding in the electrons. So 1, 2, 3, 4, and 5. All right, after nitrogen is oxygen. Symbol is O. Nitrogen has 5 valence electrons. Oxygen has 6. All right, so we're going to draw the symbol. 6 electrons. So 1, 2, 3, 4, 5, and 6. All right, after oxygen is fluorine. Fluorine has 7 valence electrons. All right, symbol is F. And then we draw them, right? So 1, 2, 3, 4, 5, 6, and 7. We got one more. After fluorine is neon. All right, so I'm going to put neon up here. Neon. Symbol is Ne. It has 8 valence electrons. Remember that all elements want to have 8, right? So the fact that neon has 8 is pretty important. It's the reason why neon as an element is actually stable. And we'll talk more about that as we move forward. But neon, symbol is Ne. Last column, column 8 or 18. Add in those electrons. 1, 2, 3, 4, 5, 6, 7, and 8. And that's it. All right, so I've done the first 10 elements for you. I did hydrogen through neon. I'm going to ask you to take about 5 minutes and go ahead and see if you could do the remaining elements, do their Lewis structure. So take about 5, 7 minutes and see if you could do those for me now.